entirely, what does that form? If you have an atom and it's neutral, and you remove an electron entirely, you make a positively charged what? It's a three-letter word. Ion. Thank you. Okay, so if you take away an electron entirely, you make an ion. If you add an electron entirely, you make another ion, but it's not the cation, it's the anion. Okay, so just a little bit of review of vocabulary there. But this time what we're going to do is we're just going to kind of adjust the electron a little bit. We're going to excite it. And when we excite it, it moves from an inner core, maybe one of these inner energy levels, and there's some atoms have many energy levels, some have one or two. It depends on how many electrons they have entirely. So if I'm looking at bismuth again, my favorite, it's atomic number 83. How many electrons does it have? That should be a 3-second question. 83. 83 protons, 83 electrons, right? So if you have 83 electrons, you've got like 10 shells, 10 orbits where these electrons can exist. But we're just going to kind of stick with simple right now. So if we have an electron, just say 1, and it's in here in the inner, one of the inner energy levels. These energy levels are simply where electrons exist in the Bohr model. They're called orbits. So I'm going to be using these terms interchangeably right now. And say you give it a little you give it a little electricity, you give it a little heat, you spark it. You don't totally take the electron away, you just allow it to get excited. So this is a photon. The light energy is being delivered to that electron, and what it has done is it's still rotating around its little orbit, but it also has jumped to an outside energy level, so to a higher energy level. That now has a new name. It's called the excited state, and that's just simply because we've excited the electron to a higher energy level. So you read about this a little bit in your Bohr model worksheet. I'm going to show you that in just a second. Now, it can't stay in that excited state for long. It's like, think about you on a sugar high or a caffeine high. Lots and lots of energy, but then what happens? You crash, right? You can't maintain that energy that long. So you're going to crash back down to ground state, which is where it was previously. So when it goes from an inner energy level out to an outer one, it eventually is going to come back down to the inner one again. So tell me, is the energy being absorbed or released as it goes from here to here? Absorbed, right? So if you're going from an inner energy level to one of the outer ones, it's absorbing energy. And as you go from an outer energy level back in to an energy level, inner energy level, what's happening? It's releasing that energy again. And as it releases, we happen to be able to see that. That's great. That's only if it falls in the visible spectrum, or in the energy that's related to a visible wavelength of light. So these energy levels, we do call them like n is equal to 1, n is equal to 2, and so forth. That n is just the term that because we label as energy level. But as you go from ground state to excited state, you absorb, and then from excited state back to ground state, you're going to then release the energy again. So you did read all this. Oops. You did read all that on the worksheet. If you can put a star by that, you did read this here, but I did see some misconceptions about that yesterday, so that's why I wanted to review this quickly this morning. So in this sample, and this is the very bottom left-hand side of the worksheet, I believe, on the Pogel. In this sample here, you can see that we're being excited from energy level what to what? Energy level what to what? N2 to N6. Okay, that's going from a low energy state to a high energy state, right? Is that absorbing or releasing energy? That has to absorb energy. So if you were trying to figure out which one it was absorbed, because that's the only way you're getting from a ground state to an excited state. Thumbs up if that makes sense now. All right. Okay, so what are the two ways I told you we could excite electrons? Heat and electricity. We're going to use electricity today to excite them. We'll use heat another day with fire, okay, to excite them on that day. Okay, so we are now down here. This is the lower right hand corner of the Pogel worksheet. So here, this is going to be relating to different wavelengths of light. And I'm going to show you how to use the actual Bohr model for this on your blue sheet in front of you. Or you maybe don't have a blue sheet accessible. Hand out a couple more. There's sorry. Thanks. Here, pass those. Okay, guys. So look at the blue reference sheet and find the Bohr model. On the Bohr model. From the Bohr model, and I want you guys to follow the line from the drop in energy from n is equal to 5 to n is equal to 2. And I want you to tell me what wavelength that is. N is equal to 5 to n is equal to 2. Looking on the blue sheet. Shout it out. Do you guys see 434 is the nanometers it's correlating to? All right, you got to know how to use this. You get this on your test, and if you can't use it, then it's useless, right? Yeah. But I want to know the wavelength specifically. So hold on one second, okay? So on your worksheet, you saw 434 nanometers, right? And that's because that's what the Bohr model is measuring as nanometers. And that is in that little section. It's got like a little, I don't know if that's called a bracket. It's called visible light. Okay, so we know that's invisible light, right? Well, then now go down to the very bottom, which is the electromagnetic spectrum, and look for 434. Do you see it anywhere there? No, right? You don't see 434. But you see other measurements of wavelength, but it's in meters now, right? So the Bohr model has it in nanometers, and then you get down to the bottom, and it's in meters. You're like, dang it, I've got to convert. But nanometers is 10 to the 9 difference, right? Different from meters. So I want you to one that says something between 400 and 500. Which wavelength is that? Blue. So the 4.2 times 10 to the negative 7th versus the 4.9 times 10 to the negative 7th. 4.34 times 10 to the negative 7th is what this would be in meters. That's going to fall in the blue spectrum. Yeah? Yeah, Jillian?
Chart on the Google sheet, it's got in nanometers and wavelengths, between 380 and 440 or
Blue is violet. So this one is going to have a apparently less specific version. This is the 2006 version of the reference sheet, and I'll actually look and see if they've updated since then. The POGO worksheet's a lot more specific. This is a lot more generic. They want you to be able to use the Bohr model as they've noted here, though, too. So there might be a little wiggle room in the discrepancies, so thank you for telling me that. I'll look and see if the 2012 version is more accurate. And it changes in about 6 years later. So, but when you have your test, use this one, because you won't have the POGO one on your test. Okay, so make sure you're knowing how to use this one. Okay, so I wanted to show you how to use that. So back to, oops. So I think we know how to read this a little bit now. These do correlate with your POGO worksheet. They do correlate with the wavelengths of the hydrogen that were emitted from that emission spectrum. So I want to show you a little bit more about the emission spectrum before I move on. So I've got to go through a couple. Oh, yeah. Okay. So on this part of the worksheet, we actually saw this diagram, right? We're like, oh, we've got this thing this box, a discharge tube. What the heck is that? Basically, this is a glass tube with hydrogen in it. We're sending electricity, it's like high voltage electricity through it, and it's starting to emit some different wavelengths, different light. But we can't see it until we use this tool, which has a prism in it, and that's what we're going to be using today. And on the tool, you'll see these little lines that appear like this, and that's because the visible light that's coming through the slit is being diffracted by diffraction grating. So if you want to, I'll pass around a sample of diffraction grating. You can look at the lights above you, but basically it's just going to take the light and separate it into its different wavelengths. So just pass that around quickly as you guys are working, and that'll be fun for you guys to try. But we're going to see a couple like boron that have a lot more wavelengths than hydrogen does. So this whole idea has a name, and it's called bright line spectra. Write that term down. Bright line spectra, also called emission line spectra. There are two names for that. I know my board's a little hard to see. I have this on and off. I know you pass around that crown. You've got the spotlight on back here. So Bohr, he's like, okay, I see this crazy emission. So he tried to really investigate that some more to figure out why are these why are these lines, why are these bright lines being caused by the hydrogen atom? So that's when he figured out that they could excite electrons and they would fall back down. Excite electrons, fall back down. Excite electrons, fall back down. And every time they fell, they released light. And those different wavelengths of light relate to the different drops from like 5 to 2, 4 to 2, 3 to 2, and so forth that the electrons could do. So we're going to be able to see this today. We can't really see the absorption spectrum. As you can see, they're just inverses of each other. The black with the bright lines, and then this is the bright lines with black as the lines itself. So we're going to be seeing a couple of things like the bright line emission spectrum, simply based off the emission of light from what? Where's this light coming from again? From hydrogen what? From, yes, from electrons falling or dropping back down to what's that lower energy level called? Ground state, right. So the lights that you're going to be seeing are from electrons falling to ground state. So if that's all you get out of the first 10 minutes of class, that's all I need you to get. That's what's causing these different lights that we're going to be seeing. Okay, so I'm going to pause for a second, and we're going to switch modes. Any questions on this so far, guys? So far? Speak now. No? Yay, no? Okay. Do me a favor. We're going to switch modes so that we can actually have some better group discussion in our labs today. So you guys are going to be sitting at your table groups. You have a folder. There's nothing in the folder at this point in time. You have sticky notes in front of you, yes? Yes. Yes. Okay. So we are going to switch modes to a quick lesson on how I want you guys to help each other throughout this 8 weeks of research that we're going to kind of be doing together. Maybe not quite that long. But you will be switching groups every now and then. And during that switcheroo, you're going to have to kind of re-norm yourself, kind of say, okay, Emily likes to be the leader, but she's maybe not going to be the leader the next time, and vice versa. So we're going to kind of have a couple of rules for group discussion. So you guys are going to be writing down some things, so make sure everybody gets 3 sticky notes. 3 sticky notes. So as you're getting 3 sticky notes, I'm going to tell you what the reason we're doing this is so that you guys can agree on how you're going to be having group discussion, setting down some ground rules for group discussion, and we're just going to start by just having some conversations with each other. So, not quite, huh? I'm going to tell you, 1 second. So, I'm not going to have you write for 5 minutes, it'll probably be 5 to 8-ish minutes. You're not going to write a paragraph, you're going to write on sticky notes. So, what I want you to do is just personally tell me how you want to be spoken to in your classroom discussions. So, what makes you feel good? So, stay positive. So if you're trying to think about how you're going to be discussed with, so for example, I like it when people listen to my ideas, not I hate it when people are rude. So you see that's positive versus negative. Let's kind of keep it positive here, and just write down a couple of thoughts about how you would like to be addressed in group discussions. So you got 3 sticky notes. You're writing down 3 ideas or thoughts, feelings on how you'd like to be talked to in group discussions. I'm just copying my own voice. You have 3 sticky notes, 3 different ideas. After all of your group members kind of have 2 to 3 ideas based on like what they feel like they can contribute, you can read the instructions on the board. You guys can start them out. Give me a thumbs up when you're done with your ideas on your sticky notes. Okie dokie. Alright, so if your whole group is done, you can sort it out. Miles, I'll take it for now. I'll pass it on. I'm going to do a quick pause. I'm sorry to interrupt. 5, 4, 3, 2, 1. Okay, so as you guys are starting to discuss, maybe you find that you have some commonalities. Group those sticky notes together, and then you're going to come up with a list that you can kind of come to a consensus on how you're going to carry out all of your group discussions. Okay, so start to group those as you discuss.
Okay, so I feel like everyone lost the habit. So we all have to do that.
Keep going.
You had problems. So we have a list of 4 main things that we want to be together with. Surprise. If you wanted to have a credit, you would care.
I like it.
We write all our notes down. Oh, okay.
But as long as you kind of discuss and made you developed a statement, maybe a statement.
Oh, shoot. You want to okay, here. So, we should, in our group, we should all work together, we all work together. It does. It's a note we talk, but I signed it for the library. But they messed up the cap on the wire, so I had to do it again, and they tried to stop them. Oh, one set stays. Yeah, we get the comment. Here, we should all together. Wow. How about each other's ideas and you guys thinking around talking about it? Yeah, but I feel like that would be the
That shit makes all the story. Takes the keys to one paper. Oh no, she said she's good.
and lastly, lifting each other. So the thing was is that I went to A. So the Catholic exists is 160 something, and the Catholic is like 70. I don't know. So right now I see that me and Jim look like we have yeah, I know. All the communities being we've got all day. You only go to like weekends 1 day a week.
Alright guys, we're gonna go ahead and share our statements. I'm keeping us on time. Alright.
I love your shirt, by the way.
So, and in the spirit of having some good discussion, I just want to maybe have one person from your group really give us a quick statement on like what you discussed would be appropriate for your group discussions from here on out. So I'm gonna start with table 1. So somebody from your group. So look at that. Look at this lovely person. Thank you.
So it's a little bit let down, but I have it in my head.
Ready.
Okay, so just like a democracy, everyone has a voice and their signature.
Thank you. Okay, so just 3 claps. We're good. Table 2.
We said an efficient group discussion includes good enough others' ideas positively.
Nice. I like that. Okay, table 3.
We think that's important for everyone to participate, but at the same time be respectful of other people's contributions.
I like that too. So we've got some similarities. Good. You guys can clap with me. Jeez. 3 claps. That's 3 claps. Table 4. Yeah.
We said under group discussion, we all like to have the same what we do and be able to split the work we do.
Nice. Okay. Table 5.
We will all do each other's our part and hear each other's ideas.
Okay, I like it. I like it. So kind of like equal representation. Good. 6.
We said that we want everybody to do their equal share of their work and also listen to it and respect each other's ideas.
All right. So listening is important. I like that one. Table 7.
We said to have collaboration, communication, and consideration throughout each group discussion.
I like those 3 C's. Nice. All right. Okay. So last thing for right now, and I need to erase the board because it kind of covered up what I was doing. This is on the same sheet of paper you were just writing your statement on. If you are on the back of where your sticky notes were, this is kind of your contract of what we can agree on. So I want you guys to take about 5 minutes in your group, discuss these 4 questions, jot down some notes, and then we're going to kind of do one more share out. So about 5 minutes here.
Can we get paper? See, I'm looking at all this anyway, no, but what can we agree on? We can all agree on listening to each other. Who's going to be your leader?
Alright, focus for me, keep your conversations focused.
They will be forgiven.
No, that's too late. I'll give them what's called
Dude, you made them.
what's it called? I just said everybody. Okay. That's
No, basically, it's all
no, we shouldn't have to.
That's like a family. No one plays together.
Just say the group. We are the
What if I don't want to participate?
We already said you'd be very good.
Alright, eyes up here. So when the timer goes off, just try to finish that last statement and then move on, okay? So I want to make sure I got this right. For the class contract, what we all kind of contributed for the very beginning, we said, I'm just going to do like the main verbs here. So share, respect, be responsible, communication, consideration, democracy, listen, consideration of all ideas, right? And then share kind of like the speaking. So I heard like take turns. Was there anything I missed from the very beginning whenever you guys shared what you thought was a good rules for discussion? Okay, cool. All right, so give me a couple of the key points from what happens if someone breaks the contract, and I'm gonna write down a couple of ideas as we go. Okay, so I'm starting here at the front. So somebody who didn't speak last time speaks this time. Front group. It's okay. It's a tough love kind of thing, but tell me what you got. No, someone new. Yeah.
What happens if someone breaks the contract? They shall be.
Okay, I'll come back to this group. I want you guys to get your stuff together, okay? Back group. Okay, walking the plank. If I need to get a plank, guys, plank's constant. 6 by 6 2 6 times 7 is like 30. She did that for me. Thank you. Okay, if I need to find a plank, I'll find a plank. Do you have anything else to break contract? Okay, I will come to consensus on what all this means to you in a second. This group, Dylan's group. Okay, just say like, man, dude, you're talking in front of everybody. I need you to kind of get back on track. I like that. Anything else? Okay, Dylan's group. I like that. It's very loving and caring. confront, and remind of values. Okay? Group over here. Okay, so kind of say, I respect you as my peer, let's talk, and then say, I gotta bring it to the authority. Right? Okay. So warning and then authority. Okay. This group over here?
Okay, but he said that if like somebody's breaking the contract, that we'll stop and notify them that they're kind of out of hand, so.
Okay, so just kind of like make them aware, because they may not know that they are like out of the kind of the mutual agreement. Okay, so notify and then go from there. Like it. One more?
I guess we're a mean group because we said points taken off or work individually.
Okay, so that's if it's like something where it affected the end grade, and you're like, look, you didn't do your part, you broke the contract. Okay, so points taken off individually. Okay, over here.
We will enforce the rules and remind them what's appropriate.
Okay, so enforce sounds like it's gonna be something serious over there, but enforce the rules and just remind them. Okay.
It was worse.
It was worse. I'm glad we toned it back down.
Yeah.
Okay, so out of all those, which ones do you like the best? Give me the top three. The kind of main ideas I pulled away were walk the plank, which I don't know what that looks like, but that could be interesting. Tell them to stop, confront them, remind them of values, warnings, and then authority. Just notify to make them aware, points taken off, and enforce and remind. What's kind of like the best things you think that we could do? So talking to them, so stop and confront them and talking to them, okay? Okay, so try by yourselves to handle it and then come to me. Anything else right now that you like? I mean, that does do a lot. That talks about a lot. Okay, I like that. What about whose responsibility as a whole is it to enforce kind of your general rules? So you shout them out. Shout them out. Would you say, Darcy? Just kind of everyone to kind of just make sure you're on task. What else? Or who else? Say again? Everyone? Same? Okay, so everyone's just kind of be aware of everyone's ideas and enforce those rules. And then what if I don't want to participate? This is the one where it's kind of weird because you're like, you have to participate or else. But there might be some other ways. So I'm start the back group again. What if you don't want to participate?
We said that we all love to participate.
Oh, so that's not even an option. Okay, so not an option. You all will always love to participate. I got it. Next. Pull your weight, okay? And that's the thing. Pulling your weight might look different to somebody, between the groups. So think about your scientist groups, right? Well, you've got some people who are going to be, everyone's got that baseline research they got to do. But then after that, you've got this product you're making. So how do you pull your weight? Maybe somebody's the creator. Maybe somebody's the technology person. Maybe somebody's like, okay, I will be the main communicator. I will make sure everyone meets their deadline. So that looks different for everybody. So as you start to get in your groups and you start trying to assign roles, it's okay if everyone's not doing exactly the same thing. Pulling your weight might look differently. Okay, keep going up here.
Do the work on your own.
Okay, so if you don't want to be a part of the group, you've got to do the exact same thing that we're all doing on your own. Okay, so that makes it a little harder because sometimes these are big projects that you'll be working on and you got to do it all on your own. Up here.
We basically just remind them of the part they should be doing, and we should tell them they just need to be doing it.
So do it. Just do it. Okay, I already got y'all's group. Julian, Kyle, okay.
We basically said it doesn't matter, you still have to work, just like put up or shut up.
Okay, so put up or shut up. Got it. I'm going to use that in life. All right, next. Did I already get y'all's group? Yeah, keep going.
If they don't want to participate, then it's their choice. They still have to listen and respect the group, so they stay on task.
Okay, so they don't have to participate, but they have to listen and on task. Okay?
Ask them kindly to keep participating. See what would they like to do in the group life.
I like that. Okay, so say like, look, we need you to participate. Kind of give me an idea what you are responsible for, what you want to be responsible for. Okay, so treat them like a person. Got it? Okay, so I got now an option, kind of that tough love. Pull your weight, work on your own, just do it, which is kind of the put up or shut up, just do it thing. Ask kindly, and then if you want to sit there, you still have to listen. What out of that seems the best for you guys as a whole? This is like the whole class, because when you're switching groups, Kim's not going to be in that group for life. She's going to be in another group later. Then you got to have some similar rules. Kim, what do you think? What's the best one out of here? pull your weight, okay? So that's like, she's a little biased, that's what they came up with. Let's go, Rishi, what do you think's the best?
I think it's you have to keep on task and listen to
Okay, so even if you're not like a main speaker or a really active participant, you still gotta be with us, because we're a family. Okay, I like that. EJ, what do you think's the best?
I don't know, I'm pretty on that one.
So not an option, pull your own weight, work by yourself, sorry. Do it, just do it. Listen, you don't have to necessarily participate, but listen, and then ask kindly and see what they want to do. Just do it. Okay, sometimes you do have to do things you maybe don't want to do. All right, so I'm gonna I'll type those up later for us. Okay, so now we're switching modes from here. So we have a spectroscope lab that we are going to do, which is looking at the emission spectra, seeing it, and believing that these little pictures we've been seeing actually actually are in what they look like in real life. So let me find that. There it is. So pull out a sheet of paper for me, title it Spectroscope Lab. I'm going to tell you 2 important facts before we move back to the lab. This is a non-chemical lab, so it's okay. Non-chemical, non-goggle, shoes or whatever shoes you have are fine. So let me go to the spectroscopes. Here we go. So you're going to see when you go back to the lab another unit. We did talk about this unit really briefly back when we did units of the SI system. But this one's called the angstrom. It's like an A with a halo. You see it? A with a halo, right there. So an angstrom is really, really, really tiny. It is 1 times 10 to the negative 10th meters. And whenever you're looking in the spectroscope, which you guys have not seen that yet, let me show you this, right? These are spectroscopes, and they have 2 holes in the front. The 2 holes in the front, the little teeny slit, so this one happens to say Caroline on the top, the teeny slit is going to be on your right-hand side, and this diffraction grating, which is like a longer slit, is on your left-hand side. So what you do is you point the little teeny slit that's on the right-hand side, you point it at the light. When you look through it, you'll see many, many colors. And I'm just going to pass around one right now. You guys, when you get to your labs, you'll see it. You'll see many colors coming through. And if you have one at your lab station, you can look at it because you guys are sitting in the class station. The little slit goes on your right-hand side. The full, long spectrum goes on the left-hand side. And I'll help you guys when we get back there. But what you're seeing on that diffraction grating is you're seeing units of angstroms. Not meters, not nanometers. You have to convert that. So you'll be using dimensional analysis to convert from angstroms to meters throughout your lab. Not the entire time, but you'll also be calculating wavelengths of light, frequency, and energy. And so you're going to see things like this, and I will help you guys read that as we go. Where is this used in real life? Who's a star person? Who likes the universe? Girl stardust, right? Okay, so we can actually look at the universe, and we can see the different colors using spectroscopy, and you can actually see if the universe is expanding, contracting. You can see how stars are moving, how they're evolving. It's called redshift and blue shift, but that's really cool because it talks about, you can look at the composition of the universe and stars. Because different elements out in the universe, helium, hydrogen, mainly helium, hydrogen is what's in the universe, we can see how they look through spectroscopy. Okay, so when you get back there, and you're going to go back there in just 1 minute, you're going to be choosing your own groups. You don't have to stay in your table groups, but you can choose your own groups since everybody now knows how we're going to be working together as a class. You're going to be looking through the spectroscope, so you have to share. There's only like 3 per lab station. You're going to be using high voltage electricity, and I will be helping with that. But I will call you over to look at the gas spectrum as we go. I usually will call 1 or half the lab stations over at a time because I only have 2 of these high voltage things, so it's just hard to accommodate everybody at once. The light bulb system is a little weird. So we have lamps at each station, and each station has a different lamp, color, or type of bulb. So like the non-coiled bulb, which is this very first lab station so behind Jillian, that's the incandescent light bulb. But then I actually don't have a compact fluorescent bulb today. I couldn't find the coiled bulb, and I didn't bring one from home. So I don't have that. But I do have the coiled bulbs that are colorful. So I've got UV light, red, green, yellow, and one more, I think. So you can definitely look at those. The mercury, so Hg means mercury, right? mercury, or what these fluorescent bulbs are here. I'm just going to leave that one on there because I have to keep it dark in there so you can see everything. Okay, so when you get back to your lab stations, you're going to find the spectroscope lab, and then we'll start. You must get in groups of 3. 10 lab stations, groups of 3. 10 lab stations, groups of 3. Bring your calculator if you need it. So if you're at the lab station, you guys can move your stuff. Robbie's whole table, move your stuff over here. Julian's whole table, Tim, everybody. Lindsay, you guys can move your stuff to the side table.
In the summer, what do you black lights do?
What'd you say?
What do you black lights do?
They have the ability to, they have enough energy they can excite different electrons in a sample, and when they